Volumetric Karl-Fischer titration is widely used as a gold standard when determining water content in various substances. This is achieved by dosing the titrant that contains iodine, which then reacts with the water present in the sample. The reaction occurs in a tight vessel, known as a Karl-Fischer cell. To obtain accurate results, it is crucial to dose precisely the right amount of iodine. However, this can be challenging as the chemical composition inside the Karl-Fischer cell can vary considerably, and the rate of the chemical reaction with water can also range from very fast to quite slow. As a result, the approach for dosing the titrant may differ depending on the reaction rate. To overcome this challenge, METTLER-TOLEDO has developed the fast forecasting FFA Control Algorithm, or FFA, for its volumetric Karl-Fischer titrators. The FFA leverages measured data of the chemical system in the KF cell to categorize the chemical reaction as either fast or slow, enabling it to select the ideal titrant dosing approach. The FFA relies on a measured sensor signal. METTLER-TOLEDO uses a polarized double-pin platinum electrode to measure the electric current imposed by the presence of iodine in the KF cell. This amperometric indication is particularly effective for slow reaction rates, enabling us to add at least a portion of the iodine faster than the chemical reaction itself. This temporary excess iodine accelerates the chemical reaction, resulting in significantly shorter titration times. The FFA algorithm provides precise measurements of water content in a short amount of time, regardless of the reaction rate. The FFA also offers several useful features, such as a drift stability stop criterion, automatic sample recognition, and automatic analysis start. Experience the simplified life of an operator with the new EVA KF Titrator featuring the FFA algorithm. Don't wait. Check it out today.